Let's examine the relationship between special geometric lines. At the end of the lesson, you should be able to answer, how do I write the equation of a line that is parallel or perpendicular to a given line? To answer this, we need to have an understanding about the relationships between the slopes of these lines. So, on the screen, you see two parallel lines and you see two perpendicular lines. Let's determine the slopes of each of these lines. So when I look at the red line, it rises 2 and runs 1, which means the slope is 2 over 1 or 2. The slope of the blue line rises 2 and also runs 1, so the slope is 2. Let's take a look at the perpendicular lines and then we'll draw our conclusions. The slope of the red line is dropping 1 and runs 2. So down 1, right 2 would be negative 1/2, and the slope of the blue line rises 2, runs 1. So rise 2, run 1 would be 2 over 1. Now, hopefully you notice that for parallel lines, we have the same value. So my conclusion is that the slopes are equal or the same, whereas in perpendicular lines, first of all, I notice one's positive and one's negative, so the word opposite would cover that fact. And then the relationship between 2 and 1/2, you should know that these are reciprocals of one another. Therefore, my key learning here is that the slopes of parallel lines are equal, whereas perpendicular lines are opposite reciprocals. We're going to use this concept over and over as we go through our examples. So in example 1, we are asked to determine whether the given lines are parallel, perpendicular, or neither. In order to do this, I'm going to examine their slopes. Line A has a slope of 5 because it's given in slope-intercept form. Line B, I'm going to quickly convert this to slope-intercept, which gives me 5y equals negative x plus 2. Divide each side by 5. I get y equals negative 1/5 x plus 2/5. This tells me that my slope is negative 1/5. Line C is in standard form. I'm going to add 2x to both sides. Gives me negative 10y equals 2x. Divide each side by negative 10, and I get y equals negative 1/5 x. From this, I can see that I have some slopes that are the same. Line C has the slope of negative 1/5. Since both B and C have equivalent slopes, I'm going to say that line B is parallel to line C. That symbol that looks like a skinny 11, or the double L in the word parallel, means parallel. Now, line A and line B have opposite reciprocal slopes, so I'm going to say line A is perpendicular to line B. An upside down capital T means perpendicular. I could also say that line A is perpendicular to line C. In the next example, we're asked to write the equation of a line in slope-intercept form that passes through a given point and is parallel to a line y equals 2x plus 3. We're then supposed to graph both of these lines. So in order to do this, I need to consider what I know. Well, this means I need to find the equation of a line that goes through 4, negative 5, and is parallel to y equals 2x plus 3. If it's parallel, it needs to also have a slope of 2. Based on this, I'm going to use point-slope form. I could use either slope-intercept or point-slope, but since I'm given a point and a slope, I'm going to write y plus 5, because it's always y minus y1, so it's opposite, equals 2 times the quantity of x minus 4. And then I'm going to convert this to slope-intercept by distributing, which gives me y plus 5 is equal to 2x minus 8. Quickly subtract 5 from each side to change it to slope-intercept, and I get y equals 2x minus 13. Based on this, I'm going to graph both lines. The given line crosses the y-axis at 3 and has a slope of 2, So it looks like this. The equation of the line I just found has a y-intercept of -13, and since that's slightly off my coordinate plane, I'm going to use the fact that it went through 4, -5 instead, and count my slope from here. It also has a slope of 2. And if my coordinate plane continued, I would see that it crosses at -13. Example 3 is very similar. Write the equation of a line in slope-intercept form that passes through -4, -1, and is perpendicular to y equals 4/3 x plus 6. Then we're supposed to graph both lines. So it's going through this point, and if it's perpendicular, the slope needs to be the opposite and the reciprocal, so -3/4. In this one, I'm going to use slope-intercept form as a reminder of how to use that. So I begin with y equals mx plus b, and I plug in what's given. -3/4 for my slope, x is -4, I don't know b, and y is -1. So, do the math, I get +3 plus b equals -1, subtract 3 from each side, and I get -4 equals b. Therefore, the equation of the line is y equals -3/4 x minus 4. So I'm going to graph this line and my given line. So my given line crossed at +6 and had a slope of 4/3. So that's the green line you see. The second one I just discovered that's perpendicular crosses at -4 and has a slope of -3/4. So that's dropping 3, going right 4, or up 3, left 4. You can see that there is a perpendicular relationship between these two lines. In the last example, we are to write the equation of a line perpendicular to y equals 4 that passes through -1, 5. If it's perpendicular, again, our slope needs to be the opposite reciprocal. Well, the slope of y equals 4 would be a slope of 0. So perpendicular to that would be a vertical line which would have an undefined slope. If the slope is undefined, it cannot even be written in y equals form. It's written in the form of x equals. And what does x equal? Well, in our ordered pair, x is equal to -1. So x equals -1 is our vertical line fixed at -1, whereas y equals 4 is our horizontal line fixed at 4. You should now understand the relationships between the slopes of parallel and perpendicular lines, and you should be able to write an equation using this information.